Okay, so this is lesson 3.2, and this is called inverse functions. So 3.2, inverse functions. All right, the inverse of a function. This is going to be a new concept to you today. You haven't learned this before in Algebra 1. Okay, so this is a new concept today. The inverse of a function is the reflection of a graph over the line y equals x. So the line y equals x, the slope is 1 over 1. So this line is going to look like this. This is the line y equals x. So when we're finding the inverse, we're finding what a graph would look like if you reflected it over that. Okay? So we're going to talk about a couple of those, and then we're going to graph some of them. There's a 3-step process. That's it. 3 steps. Okay, so if you are like, I don't know how to do this, these 3 steps, that's it. The first thing is to switch x and y. What are some other ways we've seen y, though? What other ways do we in Algebra 2 write y? Mitchell?
Was it k?
Not k. Well, yeah, when we're talking about the vertex, you're right.
F of x.
F of x. Do you guys remember that? We've seen f of x. You're also today going to see like h of x. You might see q of x. All of those together mean just y. Okay? It just means a function. It just means y. So whenever you see those, you're going to think of that as your y value. Okay, so number 1, we're going to switch x and y in the problem. Then you will solve for y. Or some people like to think of it as reverse Pemdas. Reverse order of operations. So now you're going backwards with your order of operations. You're actually doing adding and subtracting first, then multiply, divide, then exponents, and then finally your parentheses. So we're going to go backwards in our Pemdas, order of operations. Okay? Or you can just think of it, you're solving for y. It's going to be the same process. So then when we finally get our answer, when we get y by itself, we're going to replace y with f inverse of x. So you see that I've made that little -1 exponent. That a -1 exponent means inverse. And you have to write it on there as a label, because if not, then I don't know where that equation came from. When you put the label on, you're saying this is the inverse of the original equation. Okay? So these are our 3 steps. Switch x and y, solve for y, then you replace y. All right? So let's get into this. Now, we are doing a few examples, and when I say a few, I think I have like 6 examples on here because I want you to have enough where you know what you're doing when you do your homework. So it says, find the inverse of the function. So when we find the inverse of the function, what's the first thing we do?
Switch x and y.
Okay, switch x and y. And so we know that f of x is really our y value. So I can make this a y if you want to. And then I'm going to swap these 2 positions. The 5 stays there. It doesn't change. So this becomes x equals 5y plus 1. So you see what I did? I just switched x and y. Everything else stayed the same. You okay so far? All right. So if we're going to solve this for y, what's the first thing I need to do to get y by itself? Subtract 1. And if you think about it as reverse Pemdas, isn't adding and subtracting really what comes first now? Right? Okay, so we're going to subtract 1 to the other side. X minus 1 doesn't combine, so we're just going to leave it as x minus 1 equals 5y. Now what should we do to get rid of the 5y? Leanna?
Multiply.
Multiply?
Divide by that.
Divide by 5. So we're going to divide everything by 5. I'm going to divide this whole thing over here by 5. I have y equals x minus 1 over 5. Does x over 5 reduce? That's really 1x over 5. Does 1/5 reduce anymore? No. So we can just leave it as this. Now is y by itself? Okay, so what does step 3 say to do? Replace y with our f inverse. So we're going to write instead of y, f inverse of x equals x minus 1 over 5. I don't care which side your f inverse of x is on. It can be on the right side or the left side. It means the same thing. And now we're finished with that one.
Is that all you do on these?
Mm-hmm. It is all we do, but some of these things we haven't seen before. So like on number 2, that cube thing, we haven't seen that before, so we're going to have to deal with that a little bit, okay? So on step number 2, what's the first thing I'm going to do, Braxton? No, before that. What's step number 1? There you go, switch x and y. So this becomes x equals 3y cubed minus 7. Notice I didn't change anything else. I still have that cube there. I still have that 3 there. I just changed the x and y. Okay? Now, if you think about reverse PEMDAS, addition and subtraction, is there an addition and subtraction to take care of? Yeah, there's a negative 7, right? And so Braxton was telling us we need to add 7 over to the other side. So I'm going to have x plus 7 equals 3y cubed. Okay? X plus 7 equals 3y cubed. Now, if we're solving for y, I have to determine am I getting rid of the 3 or the cube next. What do you guys think?
The cube.
The 3? Daniel, say that louder.
It's 3 because PEMDAS.
Because PEMDAS says after addition and subtraction, which we've already done, then we go to multiplication and division, right? The cube is an exponent, and that doesn't come until here. So we need to get rid of multiplication first. So we're going to divide by 3. Whatever you do on one side, you have to do on the other side. So I have x plus 7 over 3 equals y cubed. You okay so far? Now we have to get that cube off there. How did we get squares off there? Remember when we did like the x squared problem and we had to get x by itself, Mitchell?
You square the other side.
Not square it, square root it, right? So square root it, but we square rooted it because it was a 2. So because this is a 3, we're going to do what's called cube rooting. Okay, it sounds really fancy. It's not. All that means you do is put a check mark and put a 3 here. So that should be a little 3. Do you guys see where my little 3 is? Right there. So it's a little 3 inside the check mark. Okay, but whatever you do on one side, you have to do on the other side. And on the other side, the entire fraction should be underneath your radical sign, and you need a 3 out here.
Now, do we draw our square root through the 3 over here? No.
You don't know. You don't have to, I mean, we know that they cancel out like that. Okay? And so I have y left, and then I have the cube root of x plus 7 over 3. Please make sure that your entire fraction is underneath the whole check mark. So your check mark needs to be pretty big. Don't just make the top part underneath the check mark, but the whole thing. So whenever we have an exponent, we just take the square root of that, but we take a radical, and if that was x to the 4th, or I'm sorry, if that was y to the 4th, what do you think I would do? You put a little 4 in the check mark, okay? So if it's y to the 5th, You're going to put the check mark and put a little 5 in there. Whatever the exponent is, that's the same one you use in the root. Okay? So now our y value is alone. It's by itself. So now we replace y with what? F, except, what letter did I start with up here? I started with a G, right? So my final answer is actually going to be G inverse of x equals the cube root of x plus 7 over 3. So just try to remember to use the same letter that was given to you in the problem, okay? Any questions on number 2?
Wouldn't the idea be to just square both the square roots off so that they cancel each other out? In that case, since they're both on the opposite sides of the equal sign.
Right, but over here, on this side, I don't have a cube, so it's not going to cancel anything out. It only cancels when there's a cube inside and a cube root outside. Then they cancel. Okay?
Now why do we have a -1?
So that's what we said in the beginning when you weren't here, was that that's the label that means inverse. So what we're doing right now is we're finding the inverse of equations. So that symbol means
But
inverse.
isn't that generally a fraction?
What's a fraction? The cube root?
The -1 though. Negative exponents are fractions, I thought.
Yes, you are correct, but it doesn't stand as an exponent. It means it's a completely different label. It doesn't mean f to the -1 power. That's not what it means in these.
So that's why the x in parentheses is required. Otherwise, it
Right,
would just be a
right,
fraction.
exactly. Okay, number 3. First step is to what? Everyone together. What's the first step? Switch x and y. Okay, so let's do that. I think it's Miss Carolyn. That's fine. Okay, so this becomes my x cube root y minus 9.
I don't think there's anything else we can do here.
Well, you have to get y by itself. So now the question is, what's our first step? Leanna?
You want to add 9 on both sides.
Okay, does anyone agree we would add 9 on both sides? That might be our first step. Is there a problem with adding 9 on both sides?
The square root's in the way.
The cube root, it's a cube root because there's a little 3 there.
Sorry.
It's okay, you're getting used to the language. Cube root. This is in the way, right? This is protecting the -9 right now. So we can't move the 9 off until we get this shield away from it. Because this root is captivating the 9. And the 9 cannot go anywhere until I get rid of this shield around it. So think back to the one we just did. To undo the cube exponent, I took the cube root. So if I have a cube root, how am I going to get rid of it?
Cube the x.
We're going to cube it. We're going to take it to an exponent. So an exponent and a root are opposite operations. Just like adding and subtraction is opposite, right? Multiply, divide is opposite. An exponent and the root are opposite operations. Okay? So it looks like this. We're going to raise this entire side to the 3rd power. When we do that, it cancels out the square or the root sign. Okay? But whatever you do on one side, you have to do on the other side. So I cube the right side, which means I have to cube the left side, which means this x is now getting a cube. So I have x cubed equals y minus 9. Now we can get rid of that 9, right? Now it's out from under the protective shield. So now we can add it over. Yes, let's
Are
see.
you just trying to kind of like move it over and then are you going to move it back to the end?
We won't move it back at the end. Nope, we're just always trying to get y by itself.
I was going to ask, how did you get the 2 on the outside of the parentheses and like from a 3?
That's actually a 3. When I marked through it, it turned it to look like a 2.
Okay,
But this is
okay.
actually a 3.
Okay, now dumb question. Usually when you cube or square something, don't you have to like do whatever the number on the outside of the root is? Like if it was squared, we have to square whatever's on the other side of the equal sign.
Right, it was cubed, so I cubed whatever was on the other side of the equal sign, which was just x.
Okay.
Okay, so now y is by itself. So what's my last step, Cade? What do I do when y is by itself?
Either
What's step number 3?
start
Good. F inverse of x, right? So we're going to replace our y value with the f. Did we start with f? Yes, we did. F inverse of x equals x cubed plus 9.
And we can't do anything with the cube?
Correct. We just leave it as is. We don't worry about what's happening to the x. My job is just to get the y by itself. Okay?
Oh, that's one.
Okay, why would the FX be at the back of it then?
Because it's the same thing. Do you agree? Taylor, do you agree that 2 plus 3 is 5, right?
Yeah,
And isn't 5 equal to 2 plus 3?
yeah,
Does it matter which side the 5's on?
no.
So it's not going to matter which side that's on. Okay? When you're in Algebra 1, we teach you to always put the y on the left side to get you into the habit, because you're just learning about equations and you're just learning about variables. So in Algebra 1, we tell you that so that you can be consistent as you're learning the new things. But it really doesn't matter which side y is on. Even in Algebra 1, it doesn't matter which side the y is on. We just tell you that. Like when you go to graph y equals mx plus b, it's always helpful because we show you that pattern all the time.
Right.
So it doesn't matter which side your f is on, really. Okay? All right. So, number 4. Why don't you see how far you can get on number 4? Try it. Okay, so I see on most of your papers, you're subtracting 4 first, which is what you should be doing, because we're doing opposite Pemdas. Right? We're doing opposite Pemdas, so we're doing addition and subtraction first. So I have x minus 4 equals negative 1/2 y to the 4th. Anybody have an idea what we should do here? Someone who I haven't heard from today. Lexi?
Divide the new.
Okay, we need to get rid of the negative 1/2, right? So it's being multiplied, and so we need to divide by negative 1/2. What's the same thing as dividing by negative 1/2? Multiplying by the reciprocal, right? So dividing by a fraction is the same thing as multiplying by the reciprocal. So if I multiply this side by negative 2 over 1, it still cancels out that 1/2, and it's going to make it easier when I go to do it on the other side. Okay? So the 1/2s cancel, but whatever I do on one side, I have to do on the other side. So on the other side, the entire side is getting multiplied by negative 2. Okay? Take your time. Erase if you need to. You could write divide by 1/2, but that's not going to be very neat and nice. Now, can we distribute our negative 2 through?
Yeah.
Okay, let's go ahead and do that. So my next step, I'm going to have negative 2x plus 8 equals y to the 4th. Negative 2x plus 8, so I distributed my negative 2. And then I have y to the 4th. All right, we know how to get rid of a power, right? What do we do to get rid of a power?
Throw a radical in front of it.
Throw a radical in front of it and put a what in the little check mark?
3 or 4.
What number this is. So this is a 4, so we're going to put a 4 in the front of it.
So does that mean we just throw a bunch of radicals at DC?
At
And
DC.
derivatives?
Are you making a joke and I'm not getting it?
Yeah.
Oh, sorry. I don't know what.
Okay, now,
Oh, Washington, D.C.
does the 4 go inside the check thing, or does it go on top of it? Or it don't matter.
Yeah,
where
it just needs to be little, right? It needs to be like this. What I don't want to see is this. Because that means something completely different. Okay? Okay. So on the right side, the 4th root and the 4th power cancel out. So I just have y equals the 4th root of negative 2x plus 8. Now, what's our last step here? Ben, what's the last thing we do? Yep, F inverse. Now, are we going to use F or are we going to use a different letter? What letter did they give you? Look at your G. They gave you G, right? So this is really going to be G inverse of X. Okay. How are we doing on these, guys? We're okay? All right, we have a couple more examples on the back. Do you not? Oh, just kidding. So I forgot to print the second page of your notes, okay? So down the middle of your paper, draw a big box so that you can separate some problems out. So draw like a big line down the middle of your notes. Sorry about that. Okay, we're going to do number 5. So you can write number 5 down on the first page of your notes. Says h of x equals 3x squared minus 5. H of x equals 3x squared minus 5 all over 6. So we have a big fraction. Okay? Not hard problem, just we have a lot of more steps maybe in this one. So first step is to do what, everyone?
Multiply.
No.
Separate.
Switch x and y. Everyone say that with me. Switch x and y. What'd you say, Ben? I didn't see your mouth move. What's the first step, Ben? Cool. Okay, we're going to switch x and y. Now, usually we would get rid of the subtraction first, right? Because that's addition and subtraction. That's backwards Pemdas. But this 6 is holding the whole problem hostage, right? We can't do anything because that 6 is in the way. So if 6 is being divided, how would we get rid of it? We're going to multiply each side by 6, okay? So I'll multiply the right side by 6 and the left side by 6. So that just gives me 6x equals 3y squared minus 5. All right, I'd like for you to finish this one. Yes, Lexi?
Wouldn't it be, since it's a division, that'd be after.
Right, you're right. It is after the addition and subtraction in the PEMDAS. But we can't do anything with that 5 because the 6 is taking control of the whole thing, right? The 6 is affecting the entire problem. Because this is really 3y squared over 6 minus 5 over 6. So you're not really adding 5, you would be adding 5/6. Okay, so we have to get rid of that 6 first. If you're watching the video, go ahead and pause and finish. So if we have 6x plus 5 over 3 equals y squared, my last step is to do what? The radical, square root it. Okay. Now, there's a 2 here, but do I need to write a 2 in the check mark?
No,
Why not?
I did.
because it's already squared.
Because just seeing this symbol automatically means that there is a 2 right here. That's why it's called the square root symbol. That's why you've heard square root since Math B. Because there's automatically a 2 there. Just like when you have x, we know that there's really a 1x right there, right? But we don't ever say 1x. We just say x. Same concept here. So if there is no number, it's automatically a 2 there. And so we had h inverse. So I'm going to say h inverse of x equals the square root of 6x plus 5 all over 3. Please make sure that your entire fraction is underneath the radical. So your radical should not look like this. That will not be the same answer. Your radical needs to dip all the way down and get that 3. Okay?
Put a 2 out there.
You can put a 2 out there if you'd like to. Sure. Okay, questions on that?
Why does the square root have to dip all the way down?
Because it's the entire 6x plus 5 divided by 3 that you're taking the square root of.
So
Not
wait,
just 6x plus 5.
So wait, a square root can be in a fraction?
We will get to that later, but for today's lesson, yes.
Oh, good Lord.
Okay, last example. So if you don't have a place on your notes, again, I'm sorry that I didn't copy correctly. We're going to do one where we get to graph it. Okay? So you just need a graph. I mean, you need to be able to make an XY graph. It's not going to have to be perfect. Okay? So we're going to do number 8. So write number 8 down somewhere on your paper. And you're just going to draw just a brief X and Y graph. So it doesn't have to be super detailed. So number 8 says to find the function. Find the inverse of the function and then graph both the function and the inverse. Okay, so the first thing we're going to do is find the inverse, which is what we have been doing. So you actually should be able to, we're doing number 8, not number 7, so make sure you wrote it down correctly. Okay, you guys can go ahead and find the inverse. You've been practicing this already. This one's not super tricky. Go ahead and do number 8. If you're watching the video, pause and find the inverse of number 8. All right, is this what you're getting for your inverse? 3x minus 12 over negative 2? Raise your hand if this is what you have.
No, I have G minus.
Well, G inverse of x. G inverse of x. Is that what you have now? Okay, those of you who don't have it, do you have a question for me about how I got something? Mitchell?
Don't you need to, you still have to keep going on that, don't
Is my y value by itself?
you? Yeah, but then you have to divide by the 12 and 2.
So you can, yes, but you don't have to. You can, but you don't have to. Okay? But if we're graphing this, this does not look like y equals mx plus b if I'm graphing this, does it? Okay, so let's look at our original problem up top. If I wanted to graph that, I can reduce 12 over 3 to be what? What does 12 over 3 reduce to? Wow. I have a classroom full of Algebra 2 students, and I had one person answer me when I said, what's 12 divided by 3?
4.
All right. So if I were to write this in y equals mx plus b form, I would 4 minus 2 over 3 does not reduce, right? So we would leave that as 2/3 x. Now, if I switch the 4 and the negative 2/3 x around, could you graph this in y equals mx plus b form? Yes? So I would have y equals negative 2/3 x plus 4. That would be my graph for the original here. Okay, so I need you to take a minute and write that down. You need to see that. So let's do that again.
So all that's wrong with the.
No. This is the inverse, okay? This is the inverse, and we're leaving that. But if I told you to graph that, that looks like a big fraction. How am I supposed to graph that, right? So we're breaking it apart so that we can graph it. But I'm looking at the original at the top, okay? So I'm looking at this original one up here at the top. First of all, I'm going to change that g of x to be a y so that it looks more like y equals mx plus b. I know that 12 over 3 reduces to what?
4.
Thank you. Minus 2/3 x, because that 3 is going with both numbers. And now, to put it in y equals mx plus b form, I could switch the negative 2/3 x with the 4, right? I could switch those positions, because then it's really going to look like y equals mx plus b. Negative 2/3 x plus 4. So this is my original. Can you graph this line? Okay, so let's go ahead and do that. On your paper somewhere, draw an x and a y axis. It does not need to be perfect. We're going to go up how many?
2.
All right, we have forgotten how to graph. You need to be on your B, and this is your M. So your B value, which you graph first, is 4. 1, 2, 3, 4. Make a point. Then from there, my slope says go down 2, and which way to find the 3?
To the right.
If I go down 2, I'm going to the right 3. So down 2, 1, 2, 3. So I should only have these 2 points on my graph right now. And I'm going to draw a line. This was my original function, so I'm putting g of x on this line because that was my original function. That was the g of x line. Okay, now we're going to change our inverse into something that we can graph. So see if you can change the inverse into something that you can graph like we did at the beginning. So change it into y equals mx plus b. Reduce your fraction. Can you reduce 3 over negative 2? Nope, so it's just going to say negative 3 over 2x. Can you reduce negative 12 over negative 2? What does that make? Positive 6, right? Or over 1, which is still just 6, equals y. Can we graph this one? Okay. So this time I'm going up 6, making my point. And then I'm going down 3 and over 2. Down 3 and over 2. And this is my g inverse of x graph. So in your homework, you're going to be asked to graph 2 of these. They're both of them are in y equals mx plus b. It's not like you have to do x cubed plus 7. Okay? They're both like this. Any questions on graphing? Seems like we were a little rusty on that. Okay, so your homework after the test today is to do homework number 14. So you have 10 problems, homework number 14.